Hey guys, welcome to a new week of Sliceform, where this week we're going to be going over engineering drawings. Now to start off simple, we are going to be making a pair of drumsticks today, and we're going to be imagining that we are designing the entire drumstick and then handing it over to a manufacturer, and we are going to be able to give them a drawing that has all of our dimensions and all of our tolerances that we need, so that when we produce it, we know exactly what size it's going to be. For this reason, we are going to be going from a very simple design and then just kind of sneaking into the drawing aspect so we can unlock some of the important things about it without getting too heavy. As we go through our projects throughout this entire course, we are going to be using it a lot. So to start off, we are going to be converting our units from millimeters and changing them to inches. Because we're going to be buying the lumber in the US and then turning it, and lumber in the US is sold in 4/4 as a pretty standard thickness, and is also going to be what we'll be using when we turn this out of wood. We can keep this in our inches. So to start off, we are going to be creating a sketch on the very front plane, and this will be a very simple project. We're just going to be making a couple simple bits of geometry and then focusing the majority of our time on the drawings. So we'll be starting off our sketch by going into Create, Arc, and then 3-point arc. And we'll have the origin be the very back side of the drumstick as you're playing it. So let's click on the origin, click kind of up and to the right, and then make whatever arc we like, something about that. And then hit Escape. Just like always, we want to kind of throw down all of our geometry right now, then add all of our constraints, and then add any dimensions that we have. We also want to add our kind of drumstick head at the very end. So let's go ahead and go into Create again, go down to Ellipse, and then somewhere, it doesn't have to be dead on, but somewhere on the red x-axis, we can click, pull away, click again, and then move our cursor up and down. Remember, I don't care if any of this is the right scale, the right size, couldn't care less. I'm just focusing on getting all my geometry down. Then I can hit Escape again. Then I'm going to go to my line tool and click on the top point of our arc, go kind of horizontally down, click again, and then at an angle and just touching somewhere on that ellipse. You can kind of see there's a little blue X, and that's saying that it is coincidentally attached to it. And then we can hit Escape. I also want to use the line tool again to define our axis of rotation. So we can click on the origin, move it all the way over, and clicking on the far side of our ellipse. And this should be completely black because it is fully defined. But we can now hit Escape. Now for all of our constraints, it looks like the origin of the ellipse is locked into the x-axis of that, so we don't need to change anything about this, but the arc isn't looking quite right. You can see there's a little corner right there. So let's go ahead and add a tangent constraint to that. So click both sides of that, and then we want to make sure that the origin is totally horizontally compliant with this line. So you can just add a horizontal vertical line and click this point, and then the origin, and there we go, that'll now snap it. Basically, this will then just define the diameter of our piece. So to add in all of our dimensions, we would first want to say, well, exactly how long is it? So we can click D for dimension, click the origin, click the furthest point over here, and this wants to be about 16 inches. That's kind of the standard length for drumsticks. And then for this flat line right here, we want to make this 12.75 inches. Just like always, anytime you add in dimensions, you're kind of working from the outside and working in. And when I do this, you can kind of see that we've got a little bit of a mess up there, but don't worry, we can always kind of click and drag these lines so they're kind of in the right location. As we put in all of our dimensions, everything will kind of get fixed into place, but it's always nice to, well, to kind of adjust our model so it looks a little bit more accurate to what our final process is going to be. Now you can click D again, and we want to define the total diameter of this. And right now we are just typing in our radius, so we want our final diameter to be 0.565, but because we're working with a radius right now, we also want to say divided by 2, and then hit enter. And that looks a little bit more accurate. Again, our line is kind of doing something we really don't want to do. Ooh, that looks bizarre. Undo, get rid of that. We want to set the angle of this line as well. This is going to be 3.4 degrees, but as we'll kind of see when we're working with our drawings, measuring angles is kind of tricky when you're on a wood lathe, which is the tool you'd use to make a drumstick, and you're much more likely to just say, hey, at this point, this is the dimension. And then finally, let's add the dimensions of our ellipse. So the height of it wants to be 0.34 inches, and the entire width from one end to the other wants to be 0.56. Great, and as soon as we do this, our entire sketch should be black, which means it is fully defined. If it's not, you may have some trouble setting it at the origin. It may be the right dimension, right size, but it may just not have a location. If you ever want to verify that your sketch is fully defined, you can always expand your sketches and look for this little red padlock icon, which means everything is locked down in place. So that looks great. Let's go ahead and finish our sketch. And then we're just going to do a very simple revolution. So go into Create, go into Revolve, and then we want to select not only this profile, but the top of the ellipse. And then our axis is going to be this line that we made. And this is just a completely normal 360 degrees rotation. So we can just click OK. And there we go. We have got a drumstick shape. But unfortunately, this is made out of steel. That's the standard material. But because we are making a drawing, which is essentially just a reference for a manufacturer, we don't care what material it is, because we can always just say in the little note saying, hey, this is usually made out of ash or hickory or oak. We just want to give it the appearance. So we're going to type A for appearance on this, and we're going to scroll down to wood, and we are going to add a pine to this. Pine always looks really good on the appearance. So click and drag that onto your part. But unfortunately, as you can see, the grain is kind of going round and round, and it doesn't look very realistic. And this is always going to be a reference for someone that manufactures it. And if it's running in the wrong direction, then they may make it in this way. And if you know anything about wood, making it in this orientation where the grain is going well, perpendicular to the length of our piece, as soon as you hit any type of symbol, it's just going to snap. So we actually want the grain to be running with the length of our piece, which means we have to do a rotation of it. So we can go ahead and double click on this pine, and we can mess around with the rotation. So let's change it to 90 degrees, and that should flip it to the right orientation. But I also want to see, well, it's looking a little kind of blurry in there. So let's mess around with the scale as well. You can see this cube right here. We've actually got a few knots in there, and I want to see a couple of those. So we can also mess around with the scale as well. So you can see as I make it smaller and smaller and smaller, it doesn't look too good. I do want to have a few knots on there. And there we go. That looks pretty good. So let's just click done. And now if anyone is looking at this and they go, okay, I need to know exactly how to make this, it's going to be really obvious where they can see, yep, the grain is running with the length of the drumstick. So that looks great. So currently our entire CAD portion is completed, and now we're going to be jumping into the drawing portion. So to open up our drawing menu, we can actually go into our file pull-down menu in the top left, and we're going to go ahead and expand the new drawing, a new drawing from design. So as soon as we do this, we can say, yep, save it, and we're just going to call this drumstick and hit save. And then it's going to prompt us with a new dialog box about, well, what do you want your drawing scale to be? The standard is either going to be ASME, that's the American Society of Mechanical Engineers, or the ISO. This is the international standard that's used all over Europe, all over the world. But for us, let's just keep it as the American standard. Our sheet size B, the 17:11, that's the most standard in the CAD community. So you can just hit OK. And as soon as you do this, it's going to pull up with an entirely new screen that we haven't really seen before, with completely new tools up top. And really quickly, it's going to load up with our blank screen. And as you can see, we can now place our base view. This is our drumstick in a kind of top-down view. And we're going over a few of these tools today, but as this kind of looks a little bit intimidating, you'll find out very easily. It's very easy to get through. And if you have that kind of artistic inclination of what looks correct, what looks right, where you just kind of have a gut feeling, you'll do very successfully in engineering drawings. So we can just go ahead and click anywhere we'd like on the screen. Somewhere up top is fine. But now we have this little pop-up view where we can mess around with our drawings. Now our drumstick here is looking kind of small. If you imagine this is 17 inches, that's kind of hard to see. So the first thing we'll do is mess around with the scale. We want to make this a 1:1 scale. And as you can see, it kind of fits, but not really. It's kind of outside of our bounds, but we'll fix this in a little bit. The things you need to know on this screen right now is saying, what is the orientation? What is the original view that you're basing everything else off of? What is the style? Do you want to just have visible edges? Do you also want to have hidden edges? That's information behind your view. Or do you want to have the same information but with all of the aesthetic things that you may put on there? Maybe the material, the sheen, the reflectiveness. Most of the time it's just going to be the visible and hidden edges, or the visible edges. This is known as wireframe. So we can just keep everything it is right now and click OK. So currently we can now click and drag this all the way around. But the first thing you'll notice is that it really doesn't fit within our paper bounds. So that will be one of the first things we'll do. But currently this is known as the parent view or the base view. As we want to have multiple views coming off of it, this is going to be what everything is based off of. So if you have your front view, then you'll probably also have a top view or a right-hand view, and you'll also have an isometric view, which is kind of a diagonal looking down. These are very, very standard views, but as you'll see, we've got lots of different ways to mess around with this. So the first thing we'll do is jump into the Create menu, and we want to look at the Break view. So currently, as I said, this drumstick is kind of like hanging off the edges, but all of this information in the middle, it doesn't really need to be there. Like if you know all the information about, the angle and the head of it, that's awesome. You need to know the full length, obviously, and you also need to know the radius over here. But all of this information in the middle, nothing about it changes. There's no decals, there's no like hand grips, there's nothing going on, so it's kind of unnecessary to show that information. So with Break View, what we can do is basically say, yep, this is what I want to do, and I'm going to lop it off there and say all the way up until about here, all this information is kind of void. Nothing about it repeats itself, so we can just click OK, and it'll shorten it down. This is called a break view. So this kind of lightning symbol, this is saying any information that you have on either end, just continue that to the middle. We can still dimension this part, so we can say, yeah, this point to that point, it'll still recognize it as 16 inches, but it'll be a lot easier to fit inside any drawings that you have. So that if you want to put any dimensions on it, they aren't like really far apart from each other. It's all very visually easy to understand. The other thing that we want to do is kind of say, hey, there's a lot of detail over here, but currently this is kind of small to see. So I want to get what's called a detail view. So if I go into Create and then check out Detail View, I can actually make a little circle around important information and then pull that view away and expand it so it's a lot more easy to see and call out. So I'm just going to click somewhere about in the middle, pull away, click again, and then I'm going to pop it somewhere down there. Currently the location of all of our views aren't too important, but as we finish off this project, you may find that it's a lot more visually striking or visually easier to understand if those are in different locations. So whatever I make in a drawing may be completely different to how you make it, but we can just pop it down here. And again, this is looking a little small, so let's go ahead and change it to a 3:1 ratio. That looks a little better. And then when we click OK, we can see it's saying, yep, this is a detail A, just in case you have multiple detail views. So we also have a letter A. This is the radius that it's talking about, and then it will also say the scale. So you can click and drag and move this text any way we want, but keep it pretty close to where your detail is. Furthermore, some of the other views that we would like to see is perhaps the left-handed view of this part. So if we were to pull it over, we would see a projected view. So that's exactly what we're going to do. We're going to go into Create and say Projected View. Again, this is our parent or our base view, so we can click that and then pull it off to the left and click again. And this is now the left-handed view of it. And as you can see, there's a dot dash line saying all of that stuff is all in the same line. Everything that you make, whether it be a top, right, any which way, it should always be about perfectly in line with it, just so all the information of saying, yeah, imagine this part and I'm looking to the left-hand view, all that information is kept in place. So I'm going to go ahead and click this little check mark right there. And you can see what I mean by hidden edges. So even though this is a left-handed view of this part, all of these small circles are still dashed and dotted right there. So I can keep that. It's not interfering with any of the drawing, so I don't mind that. But the other projected view I also would like to do is what's called an isometric. So really, these are the only bits of information that I really need. So to actually denote all of the information that I really would minimally need to manufacture this, I can get it out of all of these views, but a really nice thing to have on hand is that isometric, that diagonal looking downwards view of a part in its kind of final complete. So that's why we wanted to put that appearance on there. You could absolutely manufacture this, but it would be a little bit easier to know what the final product looked like from a more realistic three-dimensional view of the part. So again, we're going to go into our projected view, click our base piece, and instead of pulling down or to the left, to the right, I'm actually going to pull down and to the left, so we get this kind of diagonal view. And then again, to place it, I want to click this little green check mark. And again, this is looking a little long, so we can change the scale to whatever you like. Perhaps a 1:2 would fit in there nicely. It's completely up to you. But because we want to have all the information about the final product, as this is purely just an extra thing that you can have on there, I'm going to change this over to a shaded style. And as soon as I do that and hit close, now we've got all of those knots, and you can see the grain direction running with the length of the piece. And this doesn't have to be in any specific location. I just like to put it kind of off to the side a little bit. So because this part is going to be manufactured, I need to know exactly how precise do these numbers need to be. If I say 16 inches, well, how close? Is 16.1 inches okay? Is 15.9 inches okay? Just how precise does it need to be? So in engineering, we call these tolerances. These are incredibly important to set an upper and a lower bound for exactly how neat does this need to be. But we can also say just how accurate are the numbers being recorded on our drawing as well. For example, all of the values that we put on here when we were making it in CAD, we set it to a thousandth of an inch, or a thou. And that's perfectly normal for metalworking. If I'm designing something and I want it to be really, really accurate, I'll usually set the tolerance to about a thousandth of an inch, or 1 thou. But for woodworking, I don't need it to be anywhere near as accurate as that. Wood is an organic material. It will expand and contract all of its dimensions based on humidity, the weather, if it rained 3 days ago, where this wood was, if it was in the trunk or on the branch, whether the wood is part of a sapwood or the heartwood, the species of wood. There are hundreds of different outside external elements that may make this part expand or contract. So if I set this to be a tolerance of about 1/100th of an inch, I'll be perfectly fine. Usually a 64th of an inch is the lowest tolerance for woodworking. For metalworking, it's much, much more accurate than that. So for us, we don't really need to set it as a super duper accurate value. We can just limit it to the 100th place in our decimals. So I'm gonna go and expand where it says document settings up here. Then I can go into my dimension units and click this little button right next to it. And then we get a new dialog box here. So my linear precision, which would be my linear lines, all my dimensions, this is set to the 100th place. That's exactly what I'm looking for. If I was making this out of metal and I wanted it to be to the thousandth of a degree of accuracy, then I could set it here where it says 0.123. But just 0.12 is perfectly fine for us. So we can just hit cancel. So we'll start off by dimensioning our left-handed view right here. And this is where all of our dimension tools come in. So this main one, dimension, the shortcut is D. This is a bit of a multi-tool where if you select it and then click on a linear dimension or a diameter, it'll kind of click to all these other tools. But for example, I want to denote the diameter right here, so I can just click the diameter dimension. I can go ahead and click that line, and just like we would normally place a diameter, click it again, and then this is now done. This little circle with a line through, that means it is a diameter. And I can just hit escape to get rid of that tool, and then you can see I can click and drag this, that little gray dot, anywhere I would like. If you have it really kind of close, it's a little hard to see. Obviously you don't want it to be overlapping your model, so putting it kind of close and you'll see this leader arrow pointing to the outer diameter. So moving on, we're going to be going over to this detail view over here, and we can click D for dimension, and we can now put in some of the dimensions on this view. So if I'm working on this and I need to know, yeah, well, how exactly small is that diameter there? I don't really care about the angle of it. I'm really more concerned about clicking this point and that point, using a pair of calipers and then measuring that. If it's too large, I can keep cutting away material. I can also measure the distance from this point to this outer point there and say just how long does that need to be. So normally these dimension lines that intersect with our model, usually bad form, but because we're just going to be using this as a reference model, this will be okay. So now we're going to move over to our parent view, and we can now give a dimension to this angled piece. So I'm going to select it, and then instead of moving generally upwards, you can see the dimensions actually going off at an angle. So I'm going to move my cursor to the left, and you can see it will now correct, and then we can hit escape. Now we can move over and actually start to dimension the entire length of our part. But unfortunately, if I hit D, you'll see if I try and click on somewhere on there, it's just wanting to denote the diameter, which means the only point on this that I can click is the very center. So to change this, I'm going to right click the circle, I'm going to select quadrant, and now the quadrant points that intersect with the circle are now clickable. So the left, if there was a right section here, and then also the top and the bottom. So again, I can have my dimension tool still selected, click that endpoint, click the other point, and then move upwards and click again. And you can see there's a little icon that says it is broken is also on our dimension as well. So as I'm doing this, you'll also find that you'll want to kind of click and move the dimensions just so they're kind of neat and organized. That'll make the final product just look that little bit nicer. So the last dimension that I want to put in here will be the diameter of the head right here. This was supposed to be 0.34, but unfortunately we're going to be running into a little issue. I'm not able to use that quadrant tool that we used for the very end of the drumstick, where we're able to kind of get, you know, the top, bottom, left, and right points. Unfortunately, that's just not a part of the functionality of Fusion360 right now. I'm sure they'll put it in relatively soon, but right now this will be a great time to put in a little sketch. So like I said, the drawings are just all about a way to transfer information about your model to the manufacturer. As long as they can understand exactly what to make, that's perfect. So we're going to go into the create menu and say, I would like to create a sketch, and we're going to make essentially a construction line that we can go back and edit. So I'm going to go ahead and use the line tool up here. I'm going to click somewhere about the highest point of this ellipse possible, pull all the way down and select there. Then I can go ahead and hit escape. And now this line is solid, but I want to treat it more like a construction line. So I'm going to click it, and then in this little pop-up menu, change the line type from continuous to hidden. And this will give it that kind of dashed line that tells the manufacturer, hey, this isn't actually part of the model. This is just going to help you denote some of the dimensions on there. So let's say finish sketch. So now that we have that construction line, we can now go ahead and dimension this. But strangely enough, when we click this line, it's going to show the completely wrong value. For whatever reason, this line is not the dimension of what we want, but luckily we can always edit all of these dimensions. So if we click escape to get rid of our dimension tool, we can then double click on this, and you'll see that we can change around whatever we want. So right now this line is 1.02 inches, no idea why, and then these little arrows on either side is basically saying what is the dimension of whatever you selected. We do not care what that line is, we just want to get rid of it and then type in our new value. So we want to type in 0.34 IN and then hit enter, and you can see it looks just like all of the other dimensions. This isn't actually the correct dimension of the line, but the whole purpose of a drawing, remember, is to just give information from you, the maker, to the manufacturer. That's all they care about. So currently we have a little bit of an engineering faux pas. So in engineering drawings, you never want to have two dimension lines that cross over each other, because it may signify that, hey, this weird triangular thing is actually part of the drawing. We don't want to denote that at all. So we're going to go into dimensions, and we're going to click dimension break. Now we can click these two lines, and it'll get rid of this little bit of information in the middle. It'll give us a little bit of an overlap. You'll see this kind of process if you ever do any electronic circuit boards where things just have to jump over each other, basically saying a layer a little bit. but that looks a little bit more accurate. So now we can add in any bit of information that isn't directly about the dimensions of our part. Stuff about the finish, how it's supposed to be manufactured. For our first example, which way is the grain running? So we can go into this little text menu and you can say, yeah, let me just put in a random text box. You can also put in a note, which is a leader as well, or a little arrow pointing to what you're looking at. So for this note, I could select on our isometric view, pull away, and then type in anything you'd like. So if you wanted to say, hey, make sure that the grain is running in the exact same direction as the length of the part, then that's a little bit easier to understand as some of the manufacturer where they're going, oh, this is in the wrong direction. That means that this part fails a quality control. You can put in as much information in this as you'd like, information about the finish, about what the part should feel like at the very end, what sanding grit should it end at, how smooth it should be, as well as any information that would mean this is a failed part, it does not pass quality control. If you have any cracks, any split, any mold, any beetle holes that are running through the wood for whatever reason, that means that it fails quality control and this part has to be scrapped. And then as soon as you are done typing in any information that you would like to put about your product, we can finish off on the title sheet. So the title sheet, after you double click it and you're able to edit things about it, is any other information about who designed it, who's manufacturing it, if this product has any codes to it, anything about the tolerances, any information you'd like to put in here, now is the time to do it. For example, just having a single drumstick is not tremendously useful, so it may say, yeah, when it is sold as 2 drumsticks per set. Any bits of information that you would like to put in about the tolerances or any angled tolerances, you are absolutely able to make a new text box and put it in this top window. But this is really a little bit more on the business side of where you can have a paper trail based on your part. And as soon as you are done with this, you are all good to go.